Level 2 chem, I'm starting. Very important that you listen to these instructions so that way you know what we are trying to gather as data. One of the things that I have found being a teacher of many, many years, goggles on because we've got chemicals on the table now, is that a lot of students struggle with identifying precipitates in this assessment. That is an achieved requirement. If you look on your checklist, on that orange piece of paper, I've listed identify the precipitates in a precipitation reaction as an A requirement. You can't pass if you can't do that. All right? That is why I want to kind of change. I'm trying a new thing this year. I'm going to change my approach to kind of teach you guys how to use the resource sheet and how to identify things properly. So this resource sheet here is the exact same one you are going to get on the internal. Are we okay so far? Now, the whole point of this assessment is to figure out what unknown solutions are. So if I give you a bottle and the bottle doesn't have its label on it, you should be able to follow this flow chart and figure out what it is. Are we okay so far with that? All right. Part of figuring out what it is also identifying what these random things are that say white precipitate, green precipitate, orange precipitate. You need to know what those things are. And I want to show you guys how you figure that out. So we're not actually diving into the official assessment. I'm just showing you a component of it that I notice a lot of students get tripped up on. Okay? So what I've basically done is I have changed the flow chart into a worksheet, more or less, so that way you guys can practice before we actually do the assessment format. Are we okay so far? All right. So what I will do is I will probably do a couple of examples just to kind of get you guys thinking about it. I don't want to do the full flow chart at this point. I just want to zero in on anything that says precipitate so we understand how we are supposed to be identifying them and how we combine our two reactants together. Are we good so far? All right. So on my piece of paper, so this is what I was saying, you guys might want to have a place to take notes. I'm going to have two sections on here. Just going to zoom that out a bit. The first section I'm going to be writing is my observation. So I just want to notice when I mix two things together, what is going on. Ugh, I don't like how I wrote that. I'm just kidding. This paper. I'm being very particular today. All right. So I'm writing observations on one side. And then on the other side, I will write, not like super duper far over, I'll write equations. All right, are we okay so far? Yes, no? All right, it's blurry. Let me fix that for you. Observations and equation, that's gonna be a really important thing about our standard. All right, so I just want to zero in on anything that says precipitate so I can practice how I would identify it. What you'll notice is that when you're reading these flow charts, when you get to a dead end, it identifies for you what the ion is. So since I'm at this dead end, it has identified sulfate as the precipitate. Sorry, as the ion. And in fact, specifically, this is the anion identification. So I have two different flow charts. One to help me identify the anions, the negative ions, and then the other one to help me identify cations. And the whole list has been provided for you. So even though we aren't giving you the table of ions like we did last year for the external, I've given you a list of all the ions that I will assess you on. Those ions have their charges. Isn't that nice? Now you don't have to memorize them. Yes? All right. So in this first example, we have identified a sulfate. Now I want to grab from my blue box. These are my things I'm trying to identify. And my black box is how I identify them. So from my blue box, I want to find sodium sulfate. So grab a sodium sulfate out. And from my black box, I want to grab the barium nitrate, which is this guy over here. Are we good so far? Okay. Now, what we're going to do is we're going to just add a little squirt of sodium sulfate and barium nitrate. So I'm just going to do my sodium sulfate first. Doesn't need to be much. And then I'm going to do a little bit of my barium nitrate. And in fact, not on the white paper is useful. You can see it better on the background. So what do we see? White. This is a precipitation reaction, right? Okay. Now, when you are doing your assessment and identifying the unknowns, we know at this point that this is sodium sulfate because I've told you and we've grabbed it and we can see the label. If you were doing this in the actual assessment, there would be no label. All right? But the test that you have done would have told you it's sulfate. Okay? So what I want to write down is that I've taken my observations. We have a white precipitate has formed. So we've mixed barium nitrate and sodium sulfate. Which are both colorless solutions. And that then formed a white precipitate. Let me just fix that so it's not blurry. All right, can I keep going? Okay. Next thing I want to do is my equations. Now, we are not going to be doing the same equations that you guys did last year. We're actually going to do a lot simpler ones because all I need for the equation is the precipitation identification. So when I mix those two things together, what do you, paper, over? Yep, good. All right. So this is now where a lot of students get tripped up. So I want to write the equation, and I only want to write the equation for the precipitate. I see that one thing that I've identified is my anion, and my anion is the sulfate. Do we agree with me on that? All right. I then think about what I mixed with that, and that was barium nitrate. Now, which of these two do I want, potentially? The barium or the nitrate when I'm trying to figure out the precipitate? Barium. Why do I want the barium? It's the cation. So I want to take the anion, and I want to take the cation here. Are we good so far? All right, so in this case, my precipitate should be barium sulfate. Now let's check against the solubility rules if barium sulfate would be insoluble. So I've given you the solubility rules up here. I'm just going to zoom in so we can see it. I'm going to clear it. Most sulfates are soluble, except calcium sulfate, barium sulfate, and lead sulfate. So I identified barium sulfate. So should that form a precipitate? Yes. Because soluble means no precipitate would have formed. And then except is that key word there. Calcium sulfate, barium sulfate, and lead sulfate. So since I have barium sulfate, that is my precipitate. It's insoluble, causing my precipitation. All right. So when it comes to my equation then, we want our ionic formulas. That's why we did a whole lesson preparing on that. Oh my goodness, you do not want to focus today. All right. So what I personally like to do, because I'm only focused on the precipitation reaction, I can ignore the other things in my solution. So that means I can ignore the nitrate and I can ignore the sodium because both of those are not being used to form the precipitate. So I won't include them in my equation to make sure I don't like have an extra factor I need to now balance. I don't know why that's flicking. All right, so let's draw my arrow. Now, it is really important that you are writing an arrow and not an equal sign. This is not math class. All right? Equals means something totally different. So if I see an equal sign, you are definitely 100% not getting excellence. Maybe not even merit. All right. So on my product side is going to be my precipitate, which is barium sulfate. So I'm writing BaSO4. Let me check the ions to see if I have a ratio that is correct. So I see sulfate is a -2, and I see barium is a +2. So I don't need to do anything with my numbers because they're already going to cancel out to 0. This is a solid, and this is my white solid. I like to double check when I identify so I know that I have figured out what that precipitate is. And then I write the two things that make up that solid. That is barium 2+ aqueous plus SO4 2- also aqueous, because they're both in solution to start with. I know it's blurry, I'm fixing it. They're both in solution to start with, and then they become a solid when I mix them together.
Why are you doing like that?
Why do I do what? Like what?
Like put on the front.
What's bothering you?
No.
Okay, you figured it out? Okay. The white solid is pointing to barium sulfate, the product. Yeah. And that is me completing question number 1. So you see how I've numbered all these guys and I put them into different colors so that way you guys can see them. You guys have a total of 17 different things to practice. So it's a nice little worksheet there. So this is question number 1. I know, we're tired. It's last session. All right, questions, concerns, comments? Or are we okay? All right. When I'm now done with this reaction, I can then pour it into my waste beaker and use a little bit of the distilled water to rinse it out. That way it saves us a trip to the sink. We can just do one big trip to the sink at the end. And then we do the next reaction. We're all ready to go. So that is what I want to ask you guys. Do you guys want to try to do one yourself, or do you want another example? Another example? All right. I will do one on the other side, okay? So that way we can see a cat ion too. All right, let me get a different color marker. All right. So, bathroom? My papers. There you go. All right. I will do number 4 and number 5 with you because I think that's a good way to kind of see some of the stuff when it comes to content. All right. I'm on the other side for the cat ions. All right. You see how I have labeled number 4? So number 4, we are doing the imaginary reaction. We know it's all aluminium. So if I'm going to put my sodium sulfate back into my blue box. I'm going to put my barium nitrate back into my black box. And I'm going to be looking in my blue box for aluminium. Sodium sulfate goes back into the blue box. And barium nitrate goes back into the black box. All right. We are looking out of the blue box for aluminium chloride. And from the black box, we are looking for sodium hydroxide. And we are doing question number 4. Yes.
Can we go
So I want you guys to mix these two solutions into your beaker. Not right now, you can. And write your observations. Aluminum chloride from your blue box, sodium hydroxide from your black box. On the back, we're doing the cat ions now. Other side. Aluminum chloride and sodium hydroxide. Now you guys got to get the ratio right because this one is a little bit more temperamental. Yeah?
Where does it say that?
Huh? I picked it out of my blue box because I'm looking for aluminium. I'm just looking for an ion that has aluminium in there. We might need, why is this not forming a precipitate? I might need to get you guys a stronger hydroxide because that's not really forming a lot of precipitate. Alright, it should be forming a precipitate. I noticed that mine is not, so let me just go grab some more. Alright, so when you guys do this reaction, you should, okay, we're swapping it out. So I've given you guys a stronger sodium hydroxide and that worked a lot better. And you should get a white precipitate again. It's kind of like jelly-like. Do you see how that precipitate is actually like slightly different than the one you saw in the last one? Like they're all white, but it's a different type of like white. It's more gel-like, right? Yeah, so writing down our observations for number 4, and we can cross them off the list as we answer them. So number 1's done. Number 4 is what we're working on. So we mixed. So we mixed what? Aluminium chloride. What do you mean? Why is it a different type of white precipitate? Because it's a different it's a different ionic compound. It's not the same. All right. Sorry, aluminium chloride and sodium hydroxide. Are they both colorless solutions? Yes. Both colorless solutions. And then it formed what? Yeah. Does that white precipitate look like the one we saw previously? No. And why? It's more jelly-like, and the reason why is because it's not the same ionic compound. The one before was barium sulfate. This one is what? Aluminium something. All right, so we know that aluminium in this case is my cation ion. And then we mixed in sodium hydroxide. Which ion do we want from this one? The hydroxide. Why? That is the anion. So what's the product? Aluminium hydroxide. Good. All right, now let's check our charges. Aluminium is positive 3, hydroxide is negative 1. So what do I need to do? Brackets and 3. Solid, and that is my white solid. I just want to double check. I can verify my observations.
Are you serious right now?
And then we need to do our equations. So I have aluminium, Al3 plus aqueous, plus 3OH minus also aqueous. So that's what you should have. For example, number 4. I'm just going to zoom that out.
Next one, I'm going to do one.
All right, I want to teach you guys something special about the ammonia, and then you guys can have the rest of the time to do the others, okay? All right. It is balanced. I put the 3 in front.
Oh no.
Oh, okay, just explaining why you put the 3 in front. Okay. All right, keep going. Okay. So we've done number 4. We'll do 5 as well. Now 5 is quite unique. So if we look at this, it's the same sort of thing. We are going to grab aluminium. So we're going to keep our aluminium. We are putting our sodium hydroxide back into our black box, and we are grabbing ammonia, which should be this big bottle here. From the black box. All right. We are going to do a squirt of our aluminum chloride. Aluminium chloride. Aluminium chloride. The American comes out every so often. And we're going to do a couple drops of the ammonia. Now we got to kind of balance the two. So that way enough of it reacts. There we go. All right. What do we see? What's in your beaker? Go do it. You should get something that's like a white jelly. You might need to squirt back and forth to try to get the balance right. It's a very temperamental assessment, this one. But you should get like some sort of whitish jelly. I did. I'll come over. Might need more ammonia. There we go. You might need to play with the ratios a bit, because it is a very temperamental assessment. See? Aluminium? All right. Ammonia? It's a really faint kind of precipitate that forms. Kind of like a clear jelly. If it's not working, try a different bottle of ammonia. A different bottle? Yeah, you might want to get a different bottle. Sometimes the ammonia. Oh. So the big challenge of this assessment, you're going to have to change it back and forth. So the best way to describe it is that it's kind of opaque. Does that make sense when I say the word opaque? It's not white, but it is. You see something has formed when you look through it, and it's not going to capture on the camera as well. That's what I want you guys to do at your tables. It's an opaque kind of color forms. Yes. So you know, like opal, like the stone, it's kind of like white, but it's like a cloudy white. So that's what I would describe as opaque. All right. Now, if you see like an opaque white forming, that still counts as a precipitate. Okay? So all these ones that we're looking at should form precipitates. So when I'm looking at this reaction number 5, keep it in red. Actually, no, I'll change it to pink. All right. Reaction number 5. Shh. We had a white precipitate. The cation, again, is aluminium. Now, here's the challenge. We look above, and we see that we've added ammonia to it, NH3. So then we're like, what is our anion? Ooh, challengey challenge. All right, so let me explain what's happening. So, NH3, also known as ammonia, is a weak base. So ammonia is a weak base. It reacts with water. So what happens is H2O reacts with NH3 This is a reversible reaction, so that's why I have these new little arrows that kind of go like that. You could also draw it like that. It just means the reaction's reversible. Just FYI. When it reacts with water, it forms the ammonium ion, NH3+. And it forms hydroxide. So what happens is one of the hydrogens from water goes to the ammonia. Are we okay with that so far? Hopefully. This is the most complicated thing you're going to get, probably. All right, keep going. Yes? No? Repeat? Okay. So, ammonia. When I mix it in with water, it reacts with water. What happens is water will give one of its hydrogen ions to the ammonia, forming NH4+, known as the ammonium ion. Since water has lost its hydrogen, what is left over is OH-, the hydroxide ion. So what that tells you is that when you are doing reactions with ammonia, the anion for that reaction is hydroxide. I'll write that down. When you have reactions with ammonia, the anion is hydroxide. So when we see this white precipitate that is formed, this white precipitate that is formed is the same as the one in the previous reaction. And if you remember, the one in the previous reaction was kind of like that jelly-like consistency as well. Same sort of thing happened, just not in as high a concentration, because there wasn't as much hydroxides. I probably should have given you more concentrated ammonia. Can I move it? Yep. All right. So if I was to go back to here, and I was to write down what was happening, we mixed ammonium chloride, aluminium chloride, what's what? Aluminium chloride. We mixed this with the ammonia. Yep. Both what color? And then did it form a precipitate? Yes. Sort of, yeah. I would say yes. And it was what color? If it's opaque, it falls under the category of white. And if we're not sure, we can always look at our flow chart. The flow chart says it's white. All right, if I was to do my equation, actually I'll keep it like that so that we can see all of it. All right, what was the product? Aluminium hydroxide again, which is my solid. That was white. The reason why is because we had aluminium as my cation, and my anion, because it's from ammonia, is the hydroxide. So you gotta watch out for those ammonias. Those ammonias are secret hydroxides. And then if I was to do my equation, it's the exact same equation. Cool. Questions, concerns, comments? Or are we good? Does it make sense? Hopefully. All right. How much time do we have left? I don't trust my log on my computer because it is not great. We have about 6 minutes left. Okay. We should probably clean up, and what I'll pass out is the homework, which is our SciPad work. We will continue this on Thursday's lesson, so you guys can get some more practice at it. What we should do is we should keep our boxes set up as is, so we don't need to remake them. So I'm just trying to think what would be our best option. I'd like them on a trolley, but I don't know if I have any more trolleys. Huh? Hold on, big one. Yeah, big one goes back in the black one, small one goes back in the blue one. Let's put them back on the back bench and I'll figure out where to store them, okay? So let's keep our equipment, everything that we are using. You can put the distilled water in the little beaker into the yellow beaker. Where should you go? Let's do, hold on. All right, rinse out the yellow container. You can stack the black container onto the yellow container, and then you can put the beaker and the distilled water bottle into the black beaker, so that then collates some of the space down. And then we'll just place the black and the blue ice cream cans at the back of the classroom so we can reuse it. Okay? Now I'll pass out the homework.